Hello there, you're joining me today with the new product that we have to look at, which is a mobile repeater used for cellular retransmission or repeating. A bit like a transposer really. Takes an off-air signal from outside a building on the outdoor antenna and then amplifies the signal that it receives from the cellular towers and then broadcasts it out on the indoor antennas, which will be a network of antennas in the home or the business which redistribute the signal to different rooms or corridors or offices within a building, and then obviously likewise the transmit path back from the cell phone to the mobile phone mast would also need to be amplified and sent back out to the outdoor antenna as well to improve signal strength both ways. So that's what this does. It's an amplifier that fastens to the wall in a building, an outdoor antenna, an internal antenna. The internal antenna can be single if you're only covering a small area, or alternatively you can feed the indoor antenna to combiners where you then split the power to different aerials which can be located in the ceiling voids of every room in a building or corridor. On the bottom here we have GSM, DCS and 3G switches. So this switch is for DCS, this switch here is for GSM, and there's another switch as well obviously for 3G. So that's why we've got the three switches. Now we've got the power lights for each band. So basically GSM works on 800-900 megahertz here in the UK. We've got the 3G band and the GSM DCS bands all segregated on different frequency plans. So this repeater is like a tri-band repeater. So basically any signal from about 800 megahertz to 2.5 gigahertz, this will repeat it both ways bidirectionally. So if it picks up a signal on the indoor antenna, it'll amplify it and rebroadcast it out on the outdoor antenna, and likewise a weak signal that's been received on the outdoor antenna from the cell tower, it will then amplify that and rebroadcast it on the indoor antennas. And so you can select different frequency bands on and off. Works from 12 volts DC. It's only a small signal amplifier, it doesn't produce watts of power and things like that. So let's have a look inside how it works. So inside we've got the different frequency bands, which when you look at the architecture are quite easily seen. So for example, if we look at first of all the antenna, which is obviously on the right hand side is the indoor antenna, and the left side is the outdoor. So this here N-type connects to the outdoor antenna, and the signal is split into two different paths there, but there's actually underneath the print or within the print there's a connection to this duplexer filter here. So basically to start with we've got three duplexer filters, and as you can see there we've got transmit and receive antenna, and likewise there's another one there, and then this is the same arrangement as well. So we have three bands that we're splitting the transmit and receive paths, and I think on the GSM band for example it's 45 megahertz separation between the transmit and receive frequencies. So for example we will feed in from the cell phone tower regard to GSM, say 930 megahertz, into this antenna socket, and the signal from all the bands will arrive obviously from this antenna socket and get split to the three duplexer filters. And so the 45 megahertz split between the transmit receive frequencies filtered by these duplexers, and then we've got a path of amplifiers on that side as well as a path of amplifiers on this side. So the receive band, if you like, of GSM say 905 to 960 megahertz, will be fed out the RX port from the cell tower. It will be amplified by these small signal devices, which I think are gas FETs, and then it will be passed into another duplexer filter and reintroduced onto the antenna port, and that'll be then fed off then obviously for further processing, and obviously back to the antenna, internal antenna that's used within the building. So likewise, if you're talking on a mobile phone back to the cell tower, the 890 megahertz frequency band on GSM will be received on this antenna port, obviously from within the building that the antenna's installed in, or the room. And then what that will do, it will pass the signal back down this coaxial cable into, again, the 3 duplexer filters, this one and this one, so these 3. So it's again a mirror of what's on the other side. And then, say for example, we're repeating a signal from, or amplifying a signal from a 3G GSM signal, will be passed to the duplexer filter antenna port. The transmit signal will then be at very low level. It will come out the TX port and then be amplified by these devices again, and likewise be smoothed and amplified and then filtered before leaving then the antenna port to be rebroadcast again. And that's the same for all the frequency bands. So we have one frequency band here, transmit and receive path, again another frequency band, transmit and receive path, and transmit and receive path again, and that's what we do for all the frequency bands. Obviously the filters themselves, this one's only a small one, the filters themselves will prevent signals from the opposing bands from backfeeding and then getting into a loop, or the signal being picked up and if you like, go into some kind of oscillation. So down at the bottom we've got all the voltage regulators for the power supply lines for the amplifiers. So it's fairly simplistic in its design, but obviously we have a lot of signal amplification going on. So one of the things that you've got to watch when you install these signal amplifiers is that you get good separation physically in distance between the indoor antenna and the outdoor antenna. So you wouldn't have a whip aerial on here and here, you know, just bolted on the wall, because it would tend to self-oscillate, or it will cause interference. It would loop back, it will pick itself up possibly, it would desensitize the receiver as well, amplifiers, because the transmit signal is quite close to the receive signal port. So when you're installing a repeater like this, you need to make sure that the external antenna is outside the building, pointing away to a cell tower, probably a directional beam antenna rather than an omnidirectional, and likewise the internal antenna is fed through good quality coaxial cable that can work very well at 2.5 GHz frequencies, and then be fed to indoor dome antennas, which will be mounted in the ceiling voids or in the loft of the property, but radiate the power downwards. So a dome antenna is similar to basically just a physical dome that mounts on the ceiling void with a flat plate on the back, which is made from aluminium or steel. And what that does, it prevents a signal from radiating upwards and it directs it downwards. So it's almost like a torch in the ceiling. You'll get the beam of energy from the frequency bands directed down towards the floor, rather than radiating upwards and then possibly being picked up by the external antenna. So the isolation between the transmit and receive antennas is very important when installing these. A good installation will always make sure that the transmit and receive antennas, or the internal and external antennas, are mounted very far away from one another to prevent any loop backs or any oscillations or desensitization of the receiver. So in this context, the level of signal that we're getting in from the antenna externally might be in the order of about neg 115 to neg 105 dBm, possibly around about half a microvolt in signal strength. They will only amplify what they can pick up internally. So after all the filters and the losses that are incurred there, if the signal externally isn't enough for the amplifiers to physically amplify the signal because it's too low, then it won't work, obviously. So there has to be some signal there. You can't create something from nothing. But after the losses have been taken into account, the signal will be amplified up by the order of about 100 dBs roughly, after all the amplifiers. And then obviously the losses of the antenna duplexers and things like that will bring that level down. So we're only talking milliwatts, if anything. We know we're taking a very weak microvolt strength signal from the antenna, external antenna, and perhaps rebroadcasting it again internally, at the order of just tens of milliwatts. So that's why it's very important that you get the separation physically between the internal and external antenna, because that 10-20 milliwatts can travel quite far even in a building. And obviously if the receive antenna outside that's looking at the cell tower picks up itself, then you're going to get that self oscillation loop back, and it can cause interference problems, and that's when the communication regulators get involved, and naturally it can cause complications for yourself as well as others. So the idea behind setting these up is that, as I say, you get these aerials as far apart as you can so that they don't influence one another. It's a clever idea, but it's prone to problems if you don't know what you're doing when you're setting them up. So if I have a look at some of the devices, these are mimic or gas-fed ICs that are used to obviously amplify the signal. And then we have surface acoustic wave filters as well, which is this device here, a SAW filter, which are very sharp response curves for filtering. So it's a lot of filtering mindset has gone into this design. And likewise here again we have some more filters again. So we amplify, we filter, we amplify, we filter, amplify, filter, and then we amplify again and filter. So all the way down the chain you can see the necessity, and likewise the signal going back, although that looks a bit ominous, but yeah, a bit strange that one, how it's mounted in that fashion. It's just the way that it's designed, as you can see with the second one there. Another signal amplifier. So if you like, the front end, the receiver channel, where we're receiving the very weak signal and then amplifying it, is in the very low order of signal strength, very low in level in comparison to the transmit side. So that's why we have the duplexer filters, which are there to isolate the transmit and receive paths from one another, otherwise it'll just go in a loop, so, and be an oscillator more than anything. So that's why when they designed these, we have all this screening in between, the input side and the output side. So that's what this is for. And then naturally as well, between the transmit and receive channels, we have a screening again. So it prevents channels from interfering with one another, but it also prevents the transmit and receive paths from interfering with one another. And that's why, when it's enclosed with the screening, the lid, it prevents those oscillations, those issues. Now, one of the nice things about this repeater is it has an arrangement where not only have we got the power light, obviously for the device, but we have the power for the DCS, which is controlled by this switch. And obviously you can switch DCS on and off, 3G on and off, and GSM on and off for repeat. But the lights themselves only come on when you're receiving an adequate signal strength. So if the green lights aren't on, then you will not be receiving sufficient signal strength from the cell tower in order for the repeater to work. So you need the directional antenna moving to the right coordinates to get the necessary signal strength. So you get all 3 green lights on, and that way then you know that it's repeating. So again, there's quite a few of these. There's newer models. This is only a low power model. You tend to find these repeaters are quoted in building or square footage size. So the larger the size of the organisation or property that you're trying to cover will denote the actual power level that these can produce. And some of these amplifiers are quite beefy, and they can produce quite a lot of power on the output. But again, that can introduce other issues, other problems as well. So you can get them now for 4G bands. I'm sure there'll be a 5G available at some point in the future, perhaps. Maybe not, but it depends on what goes on. But there's certainly a 3G model available some years ago, which this is obviously that model. But then they were on about 4G, making a 4G variant of it as well, which I'm sure is available, a quad bander. So this is a tri-band repeater, and that's how that works. Thank you very much for watching the video, and if you like the content, please subscribe. See you at the next video.